Hello, welcome back. This is Chapter 7, Section 1, where we're talking about exponential functions, growth, and decay. I know I'm in my third or fourth video here, fourth video, and I've talked about decay so far. Decay is kind of, I don't know, it's kind of like a nasty word. You talk about tooth decay, you have to go to a dentist, or you have a dead body that's decaying. So, decay. Decay just means it's going down. The value is going down. And this is going to be an example of that. This one's kind of hard for anyone who's ever bought a brand new vehicle, because there's always the joke that as soon as you drive it home, it's worth way less money than what you paid for it. And that's actually kind of true. Not exactly at that time, but getting close. So someone's going to buy a brand new truck for $28,000. Of course, these books they're about 20 years old, so 20 years ago, $28,000, that still would have been a pretty cheap truck. New Chevy, Fords, and Dodges are probably going to be in the 50 to 60,000 range now, at least if you want options on them. Okay, but anyway, so you're going to buy a brand new truck for $28,000. The value of this truck decreases by 9.5% each year. So if you had it for a year, knock off 9.5% of the $28,000, and if you sold it, that's how much you're going to get out of it. So that's called the depreciation, right? Depreciation. Now, in the last video, we talked about things that are rare and valuable, like artwork or antiques or collectibles, that increase in value. People are willing to pay you more for them after time than what you paid for them. Okay? This is an example of almost everything else. Things that are not rare, things that are commonplace, things that show up in lots of places, like how many Chevy trucks are there, how many Ford trucks are there. They go down in value. Now, this is where usually someone says, I know someone who has like a 1950 Chevy pickup truck and it's worth a lot of money. Well, yeah, that's no longer a truck, it's an antique. That's not the same. We're talking about just regular wear and tear, nothing special. So let's think about this for just a little bit. Let's figure out what 9.5% of $28,000 is. Let's do it pre-algebra style. All right. So if I set it up like my proportion, like I showed you, I do 9.5 over 100. And how much money is that going to be? That's going to be x over 28,000. All right, so I'm going to do a little cross multiplying here. Let's clear out what I did before. I'm going to do 28,000 times, did I get 9.5? Yeah, 9.5. Sometimes I wrote the wrong numbers down. I know how it goes. And then I'm going to divide that by 100. Okay, that tells me that the depreciation is going to be $2,660. But that's not what I want to find. Well, why'd I do it? That is how much the truck you take off of the value of the truck. How much does the truck how much is the truck worth now? I have to take the 28,000 and subtract that number. So now the truck is worth $25,340. Instead of doing that as two separate steps, we actually want to do it as one step. So if I think about this, the full value of the truck is 100%. 100% is one whole. And if I subtract 9.5%, but I got to write it as a decimal, 0.095, 1 subtract 0.095 is going to be 0.905. And if I multiply that by my 28,000, and remember, I'm looking for 25,340, 25,340. So I'm able to do it all in one step if I just do the subtraction part first. That's why it's 1 subtract 0.095 to the power of t, t being the time. And again, this is going to be each year. Remember, usually finances we talk about per year. And we're going to multiply that by the original price, 28,000. And of course, this is going to be my amount, which I should have started that way over here, but that's okay. So there's my function. You can also simplify it and write it like this: 28,000 times 0.905 to the power of t, if you want to do the subtraction inside the parentheses. Both of them are cool. It's good either way. I like doing it this way because when I do it that way, it makes sense to me, but usually some student goes, wait, where'd that come from? It comes from the whole price, which is 28,000, subtracting the depreciation. And then if you do it again, so now my truck is worth that. If I do it again, times 0.905 again, now it's worth 22,932. And if I do it again, and again, and again, look at the value of the truck going down. And again, I've lost track of how many times I've hit enter. You can probably rewind and count it. But now my truck is only worth $15,000. Down like that. Now, one thing on the side, this is bad if you buy things that are brand new. But this is why people that know about this, like me, and maybe your parents, are going to tell you, don't buy new trucks, don't buy new cars. I have not bought a new car in years. And that's not because I'm a poor teacher. I'm doing okay. That's because the last vehicle that I bought had a sticker price of about almost 2.5 times what I paid for it. Yeah, about 2.5 times what I paid for it. Because it was 5 years old. So I got it at a discount. And even, you got to pay for some of the miles and stuff, but it's not brand new. But still, I was able to save some money that way. Plus, it was the truck that I wanted. Okay, so this is my function. Now I can do this again. I'm going to y equals 28,000 times 0.905 to the power of x. And if I look at my table, there's my 28,000. Now it's 25,340. Now it's 22,900, 20,700, 18,700, 16,000, almost $17,000. I'm just rounding off. I'm not going to read the numbers out. You can see them. After 6 years, it's 15,000. My question says, when will we predict the value to be $5,000? I can do that with my table. So let's keep going. I'm looking for the value to be 5,000. There's 5,130. At 18 years, it's going to be less than $5,000. Okay. But the problem actually says use the graph. So just like last time, oh, did I have a graph on here? Yeah, it's going to look like that. And you can also go in here, you can do this, y equals 5,000. And I need to go further. Okay, I know it's going to be 18. This only goes up to 10. So I can change my window, my x max, let's make it 20. Boom! Now, the resolution on here, this looks like an old video game. The resolution on here is not very good. Desmos is better. You can do this on Desmos. There is a way to do this. I'm going to calculate an intersection, which is number 5. These are my two graphs. Let's move it over to where I think the intersection is going to be close to there. And I got 5,000 at 17 and a quarter of a year. Okay. However, I also did this. This is the same graph that I stole from Desmos. And I basically do the same thing. Here's 5,000 And you know, last time I didn't do too well with this, so I have a where'd it oh, here we go. So I'll try to draw this with a straight edge. Might have to do it a couple times. I come over like this, and about like here. And of course I'm doing this by hand, so it's not going to be perfect. But it looks like they're going to intersect about right here. Dot, 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 dot. Here's 16, here's 17. So yeah, about 17.25 or 17 years and 3 months. That's when it's going to be worth around $5,000. Okay, we'll see you in the next video.